Hi, psychology class. This is Dr. Benhar. I wanted to discuss a topic that sometimes is confusing to students called correlation. When you see the word correlation, you should think of relationship. When we say that two variables are correlated, we're basically saying that there's some relationship between them. A variable is anything that changes or varies. For example, height can change. It could be a person could be 5 feet tall, a person could be 6 feet tall, a person could be 7 feet tall. Weight is another variable. A person could be 120 pounds, 130 pounds, and so on. These are things that psychologists look at in research. At times, we perform a correlational study instead of an experiment because it would be unethical to perform an experiment in these cases. For example, if we know that there is a correlation between being abused as a child and possibly growing up to be an abusive adult, we can't perform an experiment in which we would do random assignment and assign children to be abused by violent parents, abusive parents, and then have a comparison group in which we assign kids to not be abused. That would be obviously unethical. So in some cases, we can't determine exactly cause and effect, but we can see relationships that give us ideas for future experiments, or as I just indicated at times, it may be unethical to perform that experiment. So when we say variables are correlated, we also talk about two aspects of correlation. One is the strength of the relationship, in which it goes from basically 0 to 1. The positive and negative numbers are things that we will talk about in a minute, but right now we're looking at the strength of the relationship. Any variable that has a correlation coefficient that's closest to 1 is going to be a very strong or almost perfect relationship. Anything that's closer to 0 means that it's actually a weaker relationship. So this is something for us to keep in mind, and we're going to come back to that a little bit later. Remember that when we talk about the strength of the relationship, it cannot go above 1.0, and if it does, then it means it was a computational error. So let's take an example of some things that are related to each other. I think we all agree that maybe income and education are correlated. In a minute, we'll talk about the difference between positive and negative. But when we talk about income and education being correlated, basically what we're saying is that people who have higher education may have a higher income. It's not going to be a perfect correlation because that would mean whoever has the highest education would make the highest income. But we know, for example, Bill Gates has not finished college education, and yet he's the richest person in the world. So it's not a perfect correlation, but when we talk about correlation, we're getting a number from 0 to 1.0. Smoking and health are also correlated. Generally speaking, people who smoke more have poorer health. Now, when we talk about the direction of the relationship, there's something called positive correlation. Positive correlation does not mean a good correlation. It means that the two variables are going in the same direction. Let me go back to this. So, for example, if we talk about height and weight, they are positively correlated. Generally speaking, people who are taller tend to weigh more. Now, we're not saying that whoever is the tallest person weighs the most. That's probably not accurate. But when we indicate the strength of the relationship, for example, we could see here that the strength indicates that it's 0.7, which means that it would be a strong correlation between height and weight. Now, I made up this number 0.7, but it illustrates the concept of positive correlation. Another example of two variables going in the same direction are things like age and medical conditions. Generally speaking, as people get older, they have more medical conditions. Something that's more relevant for you, how about the hours a person studies and the grades that they get? Generally speaking, people who study more tend to get higher grades. It does not mean that whoever studies the most necessarily gets the highest grades. That would be a 1.0 correlation. There are other variables such as the study strategies, a person's awareness of the material or previous knowledge, and so on. Another example of positive correlation is stress and heart attacks. Generally speaking, the more stress, the more heart attacks. And we already covered something like education and salary are positively correlated. Negative correlation does not mean a bad correlation. It means the variables go in opposite directions. What that might mean, for example, is that as the amount of exercise increases, people's body percentage of body fat tends to decrease. In other words, one variable goes up and one variable goes down. This is noticed here as the negative sign here. A 0.70, negative 0.70 or a positive 0.70 are equally as strong. The positive 0.70 means that the two variables are going in the same direction, and the negative 0.70 means the variables are going in opposite direction. Other examples of negative correlation are things like serotonin and depression. As serotonin increases, depression tends to decrease. As a person's smoking increases, health tends to decrease. And another example of the negative correlation is as a person's stress increases, their health tends to decrease. Remember, negative correlations means they go in opposite directions, and I highly recommend that you actually do arrows to indicate the relationship. By writing it down on a piece of paper, it helps you to clarify it by seeing the direction of the arrows. Here's an example of a positive correlation if it's graphed. Notice the x and y axes. What this would mean is that if we took everyone in our class's height and everyone in class's weight, let's say height was x and weight was y, and we basically put down the points there, we would come across a perfect line that would indicate a 1.0 correlation. This is a perfect line, and in research we don't really find things like this. This is an example of no correlation. Notice the points are all scattered. Here's a perfect negative correlation, which means, again, graphing the points of x and y, we could actually see that there would be a negative correlation here. Again, this is a perfect -1 correlation, and in reality you don't find things like this. Now, let's go back to the strength of the relationship. Remember, whatever correlation coefficient is closest to 1.0 is the stronger relationship, but it can't go above 1.0. Let's take a look at these examples. If you look at positive 0.5 or negative 0.80 or positive 0.73, if I'm asking the question which relationship is stronger, you're only looking at the number that's closest to 1.0. Now, ignore the positive and negative because the positive and negative here do not represent less than 0 or more than 0. It actually represents the direction of the relationship. So in this case, think of it as absolutes. You could use like the absolute sign like we learned in high school, in which we just ignore the positive negative. Whichever one's closest to 1.0, in this case it would be the negative 0.80. Another example here is positive 0.65 or negative 0.90 or positive 1.1. Keep in mind it can't go above 1.0, so that's an example of a computation error. So the answer is going to be negative 0.90 because it's closest to 1.0. Again, ignore the positive or negative sign if I'm just asking the question about the strength of the relationship. Third one, negative 0.25 or positive 0.60 or positive 0.53. We could see that it's positive 0.60. The last topic here I want to talk about is that correlation does not prove causation, meaning cause and effect. Correlations just means that the two variables are related. It cannot mean that the variables one causes the other. In order to determine causation, an experiment must be performed. So notice that we have different research methodologies, such as descriptive research, like case studies, surveys, interviews, naturalistic observations. But we also have correlational studies to see relationships, and then we also perform experiments to determine cause and effect. So here's a little bit of a joke. I wish they didn't turn on that seatbelt sign so much. Every time they do, it gets bumpy. This is an example where this character from the Family Circus believes that seeing the seatbelt sign go on is the cause of the turbulence, when obviously they're just related to each other. The third variable is obviously the turbulence. So here's an example to illustrate it. Low self-esteem could cause depression, or depression could cause low self-esteem. Or you could have third variables. Biological predisposition or distressing events could cause low self-esteem and depression. The only way we could determine that low self-esteem causes depression is by conducting an experiment, and that's terms like independent variable and dependent variable. I hope this helped to clarify. Keep in mind that there are sample questions that are in the Revel software, so please take a look at that, and if you have any questions, please contact me. Keep in mind I do have open office hours as indicated in the syllabus. That is in person. If you would like to speak to me by phone during the office hours, I'll be happy to talk to anyone and help anyone through the problems. Best wishes.